Okay. So it's very simple. What you need to know is what is the stop width, right? If we know the stop width, we need to know where are we going to place our crosscut, right? So that we can access the O board. Now, how far is the orange from, or let's say, how far is the, if you are working in the hanging wall, right? Or in the footwall. So we have the footwall drive. Now, how far is the footwall drive from the O board, right? So if we know how far is the O board, the footwall from the footwall drive from the O board, now we know what will be the length of the crosscut. So if we know the length of the crosscut now, how big is the stop itself? So we know, okay, let's say the stop is 25 meters, right? So now we know if the stop is 25 meters, where are we going to place our crosscut, right? So, if we have a 25 meter stop, now we want to place our crosscut. Where possible should we place the crosscut? Yes, we have 25 meters. For example, I'm starting from here. This is our 0, right? Then we are going to the far end here, it's 25. We assume, right? Now, what will be the distance at which we put our crosscut? Why do you choose the middle? From the transportation cost, right? And also, how can it help you in other ways? Apart from the transportation cost, what in other ways it should help you as well? In which way should it help you? Yes, boss. Drawing cone, yes. Another answer? The ventilation there is somewhere else. Another answer. You know, you can't have a ventilation list in every store. It's going to be costly, right? We have a ventilation list at the end, we have an inlet and outlet. So the ventilation list is always at the end of every drift or extraction drive. So we have there at the end there is a ventilation list so that the air can flow. Now, in which other way can it help you? Yes, boost. You're always not answering. So when are you going to give me the correct answer? When I die. Guys. And then only have people are moved to the So how can it help you? What's no, that's not the answer. The stove. No. I didn't get the question. I'm saying we have a stop of 25 meters. Muteng has given us the answer that we should place our crosscut at the middle, which is correct, right? Because we want to access it. So he said transportation. Then there is another answer. How is the crosscut going to help you to facilitate you work in the O board, right? Because you are creating that crosscut, one, to access the O board, not so. You want to transport your O. And what else, right? What are we going to do? Bundle. What are we going to do? Yes, boss, no, okay, you can even give to the rate. It's fine. No, I want to answer the first question. So, you just create the crosscut, then what else? Okay. You create the crosscut, then what else? Are we going to create the crosscut with our team? So, what else? Think, my brother. Mudori. We have created the crosscut, we have excavated. What is in it? Now, given you the answer. Yes, Muma. We have those, right? Because the crosscut is coming from the footward drive. Okay? Because for you to get to the crosscut, it is crossing the O-board. That's why it is called the crosscut, right? Now, you can't create a crosscut before you create a drive, the footward drive, right? Because you need to pass through there. Now, you have created, you have excavated, you have transported the waste, right? Then what comes next? Yes, brother. Yes, so you need to create the ring, right? So now how are you going to drill? Because you are going to use that, then you drill, right? How do you call that? That drill. Yes, so you are in the drive, you don't need a drilling chamber. Yes, because that will be another cost. You are brainstorming. You brainstorm yourself. Okay, so that is the issue, right? Now, let's open this funny Surpac. Okay. You know that these tools for underground mining, you can add tools for underground mining, which are here, right? When we add them, they'll become like that. But also we can go in design. Surface mining and underground mining is in the design, right? So it's the way you want to facilitate your work, okay? So now how do we create the crosscuts? To create the crosscut, you have these tools here. You have a panel, right? This is the panel here, the first one. So for example, if you have two ore bodies that are adjacent to each other, if you saw the question for last year, you have two adjacent ore bodies, right? So if I say, let me create a footward drive, right? Create a footward drive. Now, we have another ore body which is this side, right? And I need to access both ore bodies. So there are two ways. If the rock mass in between those two ore bodies is stable, right? We are going to create a drive on the middle, right? Then we access the two ore bodies together at the same time, so that we reduce the development of those crosscuts, right? But if it is not stable, then I have to pass through this ore body. Now, if I extract this ore body first, then the other ore body is remaining here. We have created instability in this other ore body, right? So you need more support. So now, if the ore body, the first ore body is as high grade, the company is going to decide, me, I need to make money, right? So we start with this one, right? And that's where the drives, the crosscuts are coming from. Now you have created instabilities. Now you have to extract that one after. So it will be very costly to extract the other ore body after you have extracted this one. So you have to make a better judgment, right? So we can use these tools. You can create the crosscuts at the same time. They are going this way, they are going this way. We reduce on time, right? So we use that one. Now, if you remember, this is what we had, right? So here we have the hanging one, the footwall, right? I'm going to edit these strings. I'm going to use one, right? And you are going to develop the whole underground design from beginning to the end, okay? Now, we have this. One, we have tempered with them. We have its cross-section area, which is the profile, right? So the profile is already there. Now we have disturbed that. And yes, Bakuru, what do we have there? We have a string here, which is in red and a string in white. Which string number would the white one have, possibly? What is the string number for that? The white one. It's 1, right? Now, Boost, how many strings do we have in Surpac? Huh? And this is not 0. Oh, yes. Yes, in my mind. How many strings do we have in Surpac? I've been preaching Surpac from the beginning, so you forgot. You are preaching Surpac, Mr. Peter preaches the word of God. That's longer with your friend. Okay, boss, just kidding. Yes, brother. Tell us. How many strings do we have in Surpac? Jerry. No. How many are there? There are 32,000 strings in Surpac. So each string is assigned a color, right? So it is possible if we say string 1, I may make a mistake. But because it's the beginning, there are very few strings there. It is going to have string 1, right? So if we don't know, we use a string range. So we confine it within, start from string 1, comma, 32,000, comma, 1. So start from 1, go to 32,000, come to 1, because I don't know, right? Then I'll remove those. Okay. If you don't understand it here, you will answer 0 or 9, like Jerry, my friend. Right, Jerry? Yes, so we have this. So what I'm going to do, I'm going to work on 1. I don't need to develop everything. The procedure is the same for all, right? So what you are going to do is, you have different levels so that you can't confuse yourself as you are designing. We are going to delete the hanging wall drive. We remove it. We remain with the footwall drive, right? Then from that footwall drive, we are going to create now the crosscuts, right? Listen, okay. Moment. Yes, boss. Okay, so now we have all these. So let me check which one I'm going to use here. Okay, I'm going to work with this one. You can see it, right? So I'm going to delete that. Yeah, delete that. Delete this, that. I have not deleted the string in general, the original string, right? I'm going to save it with another one. Now I still have these strings that are for the cross-section area. So these ones, I'm going to say delete range of strings, right? So this range of strings, I'm going to say, actually, I can avoid using this range. I can just say delete this. Let me see what is happening here. Okay, I'll delete the string range. I'll just click 1 so that we just remove that one, right? So we use the string range to remove all those because they are a lot. What I want is the string range for this red one, I think, which is 8, right? So those others, they should go. I just want to use this one. So I'm going to save this one as a foot wall D1. Okay? Then now we will press ERTM to erase the temporal markers. So we have the string, which is this one. So we have saved this one. It can be, we can save it with a level. We can check here, for example. I can say, let me check its properties. We check its properties. What is the elevation? This is the, okay. The elevation is 104, right? So also, instead of confusing ourselves, we can save this one as photo 104. Delete there and save it. Then I'll bring back the drifts. For example, I want to work on, we want to work with this level here, right? So again, we are going to go back, we start deleting the strings. Okay, so we have deleted those. I'm going to check the string number for this string, right? Or the elevation, the surface reduced level. We have checked it, see, 904, right? Then I'm going to delete a range of string, which is 1, right? Then we save this one now. Save as foot wall D 904. Save ERTM. We erase those temporal markers, right? So you can do that for all the strings because we are following the profile of the whole board, right? So now we have done that. Now we are saying, for example, we are saying each stop is of 25 meters, right? So we say the crosscut is going to be at 12.5 meters, right? That will be the spacing, right? So we are going to put it at 12.5. Now, for the sake of the class, because I will take a lot of time to create for 12, because that's a long distance, right? I'm going to use, it's not ideal to use 50 meter stop, right? I'm going to use a stop for 50 meters, so that our crosscut is going to be at 25 meters, okay? For demonstration purpose. That's what we are going to have. I didn't mean in there that when you go to the mine, Mr. Songa said, no, we use 25 meters, 50. It is standard, right? I didn't say that. Okay? Even if he is crazy, he's failing. I will continue teasing him. You know what that means? What does it mean? No, say Munwama or Wanwama. What does it mean? Yes, Wanwamuru. So Munwamuru. Okay, alright. So we have that stuff there. You know these days of this COVID, 2019, you have a mask. So even if you are laughing, people they will know to know. You just like yourself there. You are laughing. Yeah. The papers they say at least now Keegan. You know Patrick Pitchpora. So there's Keegan Pitchpora. This man don't know about my child particular twin sakato. I can't put on the book to our brigade at the chapel and the very much of you. Things I can do, I should was this man go like okay, don't worry about that. Let's continue. I thought maybe Jerry can sleep. Can I continue? Right? He's tired. No. Jerry is attentive. Okay, so this is what we have, right? Now, let's do one thing here. Why do we use surveyors? Yes, come. Why do we use surveyors in the mine?
We need to know where we're going
with precision, right? We need to know the orientation. Am I going in the correct direction? They are saying the whole body is trending maybe at 100, right, degrees. That is the azimuth or the bearing of the whole body, right? It is striking at 104 degrees. That is the strike of the whole body. So now, if I say, it's because I'm a mine engineer, I'll just design. Even if I go at 40 degrees, it's fine. You'll find yourself in Shanghai, right? Without finding the whole body. So we need to follow. So now, the step that we are going to take is to know from the strings. Here we have already the coordinates here. It is coordinated. So we need to know how is that string trending? What is its direction, right? So we need to measure the bearing and distance, right? Now, if you check this string, it has got a lot of points, right? There is a point here. Again, there is another point there. So we need to check the bearing of a segment. We design for that. Then we change again, we go to the next segment, right? We have points. Don't you get it? I'm saying, if you see here, what I'm trying to explain is, there is a point here and there is a point there. At every curve or corner, there is a coordinate, right? And in between also there are some smaller points which we can display. For example, let's display them so that we don't confuse ourselves. We can go to display points, markers or numbers. So I can display the point markers, let me just say, by that, right? So we have a point and there is a point at the middle. Then there is a point here, right? So we are going to measure the bearing from this to that. There is a bit of some difference there, right? But I think it's minimal. So we can consider from here to that point. So what I'm saying, we are going to measure the bearing from this point to that point. That will be our first segment where we are going to measure the bearing of that whole body, because that came from the whole body. Two, when we say bearing and distance, we are getting the distance and what is the bearing, not so. So we'll get both of those. Yes, Robert.
What is the minimum segment?
There is no minimum segment trend here, but you know that here what is there? It's at a distance, right? It's not that this string is going to have a lot, unless you input some. And when we are digitizing, possibly if we are dealing with nickel, right? They have classified those resources that they are in green because there is lead, yellow, and green, right? Green meaning they are exploitable resources, right? So now if it is in green, if it is nickel, according to, like in Cuba, the Cuban norms or standards, it has to be 32.2 meters apart. So meaning they have done the exploration at 32.2 meters, right? They have done the drilling and they have confirmed the whole bodies there. Okay? Then they will have also some borrow pits where they have gotten some samples. You know a borrow pit, right? A trial pit. Oh, not a borrow pit, it's a trial pit. What is a trial pit? No. Okay. I confused the terms, you might get confused. What is the difference between a quarry and a borrow pit? Right? The difference between, there is a mine, say an underground mine, right? We have a borrow pit and we have a quarry. What is the difference? Yes, Kinsey. Kissinger. Kissinger. No, his name is Kinsey. Kissinger. No, this is just a difficult topic. Kissinger. What is the...
Like the quarry, this angle is high.
No. They were survivors.
Yeah, just a thought. I think a quarry is more an area where you get the aggregate, and a borrow pit is where you get material external.
You know, you are in a correct direction, but you confuse yourself. Think twice. You are correct. You are almost correct. Sand is an aggregate as well. He has an idea. He's correct. No, a quarry also is aggregate. Sand is an aggregate. Coarse aggregate, fine aggregate. Right? Sand is fine aggregate. When we talk of, let me say, like, when you're making bricks, right? Like if we check here, we have rocks here, some rocks, right? So these rocks, they are coarse aggregate. Now we have sand, fine aggregate. Then we have cement, right? Then we have water, then to make this concrete, right? Now, what is a borrow pit? And what is a quarry? What is the difference? You should know that as mine engineer. Fifth year. Okay, you should go research on it. I'm just going to give you a short terminology. A borrow pit, when they are constructing a lot, right, they get gravel somewhere. Where they are getting that gravel, it's a borrow pit. Okay? Now, quarries where we are doing those blasting, there are two types of quarries. We have a quarry where we are producing aggregates. Then we have a quarry for dimensioned rocks, right? For example, marble. The marble for tiling, granite for tiling, right? Where they are getting those materials, that is also a quarry. It can be underground or surface, but that's a quarry. Then we have like Shilanga. Shilanga is producing cement. That is a quarry. They are getting limestone that they crush, they add other materials, they produce cement. Then we have quarries like international something, as you are going to the airport. You go this way. There is a big quarry there which has been there for so long, right? That's a quarry. They produce those aggregate for construction. And we have also these, I think they should be the dark people. There is another one, this one, the famous, they produce even cement as well. Amaka, Oriental quarries, right? We have the Orientals. Okay. That's for you. So, now, okay, we go back. You want a break? Okay. Eh? Okay. So now, okay, let's go. Now we continue with the design, right? So what I was saying, the first thing we are going to do is to know the direction and what is the distance of that segment, right? At now, like Tambitimo was asking me, I don't know what is the distance as well, right? I can only confirm that after we check, right? So we place BD and we can check now the bearing and distance of this, right? So it is telling us that the horizontal distance is 322.298. That is the horizontal distance of this segment to that point, right? So if we divide that by 25, we are saying each stop is of 50, as we are assuming, right? So we are going to have, at 25 meters, we are going to have a crosscut, right? Now, also here, we have a bearing of 258.211. Okay? We have that bearing. Then also we have decimal degree bearing of 258.1238. That's the decimal degree bearing that we have there. Bill. Now, I want you to change. This is in degrees. I want you to change this to decimal degrees. How do we calculate? Tell us how we calculate. What we have is decimal degrees. Oh, we have the degrees here. In degrees, the bearing in degrees, which is 258.211 degrees, right? Now we have here, what we have here is 258 degrees, seconds, and minutes. So I want you to change that first one in seconds and minutes, right? Degrees, seconds, and minutes. How do we calculate that? You are an engineer, come on board. How do you calculate that? So it's how do you change? Yes. How is it on a calculator? Why do you want to use a calculator? So if you have no calculator, you know what to calculate. Okay, what is the principle, Jerry? How do we calculate it? First of all, we should define what is a degree in minutes. Right? 1 degree is equal to 60 minutes. Are you sure? 1 degree is equal to 60 minutes. Engineers. So, okay, let's do this. Excel, right? Let me open the Excel. You guys, you should be serious. You know, I missed the class for last year. I miss them a lot. No. Okay, some in this class. Countable people. Huh? I know some of the people, I'll miss them, but some. Like I've been away like, Huh? I went like, what do you think? I should remember you, my brother, right? Okay, so what we have here is this one. I want you to be good. So what we have is that one, right? That is the degrees, right? That's what we have. So now we are saying here, we are going to get the degrees, right? So I'm going to say, let's calculate the degrees here. Then I'll calculate the minutes. Minutos, segundos. Okay. So we are saying the degrees is equal to this one minus 258. The degrees is that minus 0.211. That is the degrees. Now the minutes will be equal to this one, right? Minus, I'm going to put this in brackets. Minus 258 close bracket times 60. Okay? Then I'll open bracket again. I'll put this in brackets. Then minus 0.66. Okay? Then now I'm going to calculate now I'm going to calculate from this one minus, right? 258, right? Yeah, 10 times 60. That's what we have, right? That's what we have there. Then I'm going to open another bracket here. And I'll close it. Then I'll subtract 12, right? Now, after we subtract 12, I'm going to open another bracket. I'll close it, then I'll multiply by 60. Right? Confusing, that is not the answer. So now, let's check what we have here. So we have Surpac has done a bit of some round off, right? We have here 258, 1238, right? What we have here is 1239.6. Is that Surpac has done a bit of some estimation, or maybe it's because of fraud number, right? So that is the answer there. I don't need a calculator, I have a computer, right? So understand the principles well. Okay, money. So now, we have known these parameters. We have them now. Now the second position, or the next step, is us to start developing now the crosscuts, right? So now, the sample body, I'm not sure what is its width, right? So I need to know the width, because you need to have some escape somewhere, right? That crosscut is going to surpass the whole body inside. It will be going somewhere inside there, and it will go in the hanging wall. So now, we need to know what will be the length of that crosscut, right? That's what we want to know. So now I'll go back to okay. Let me check this one. So we are working at this, right? At this level. So I'll just say, let me check BD. I'll check from this point to that point, right? And we have the distance of 339, right? 339. Oh, 139, right? That's the distance that we have between this and that. So that's the thickness of the whole body at that area. So we want it to go, for example, it will go 3 meters in the hanging wall, right? And our excavation in the foot wall is at 25 meters, right? So we are going to add 30 plus 139. What are we getting? Huh? 169, right? So now the length of that crosscut is going to be 169 after it is completed, right? So now, we are saying the excavation, due to geotechnical investigation, we have said the footwall drive is going to be constructed. Okay, we can reduce it to 15, right? If it is competent rock, so that we are near, right? So we put 15. That is the length from the footward drive to the O body. Right? Now from there, we also have the 5 meters, we are saying 5 meters, it will protrude into the O body to the animal. Right? So that is the 5 which made it to be 30. You get it, right? So let me use 15 plus 5, 20. 20 plus 1, 39? 159, right? So that's what we are going to use. So that's those, they should be judged by people from the geotechnical group, right? Yes. Unza.
If I say the football drive is not in contact with the football, why are we not considering that distance from the football drive up to where?
What are you saying?
We are saying the football drive is in the football, in the west, not in the.
That's what I've just explained, 15 meters. You are confused, my brother. Okay, let's make it simple as this. This is what we are saying. Let's create, this is our whole body. Okay? And this is our whole body, and it has that really. Right? That is its thickness. Now this is our extra, this is, let's say, this is in the footwall now, we are in the west here. Right? Then we are considering this space here to be 15. So now I'm coming from here, I'm entering from here, I have a 15. Now this is a footwall drive, right? Here is a footwall drive. So we are entering from here. I think you get it here. Now we say again, we are going to get into the hanging wall. For example, if you want to go on this other side, right? Maybe to hide yourself because of whatever you will be stuck inside. That you die like a rat. So we have a 5 meter here, right? We are going inside here 5 meters. That's the 5 meters I was adding. We can even put it 3 so that we don't increase on the cost of 1, right? That's what I was saying. Maybe you have gotten experience.
Yes.
Okay. My explanation is good because I have everything here. Okay, so we continue. Mbeo ambo tu majuju, eh? Nikisinja? Okay. So now, let's measure again the BD. Let's first display the point numbers. Then we are going to BD the bearing and distance. Then we measure. Okay. Was this the one I was using last time? Is this the one I used? I think this is not the string that I used. Let me check. Maybe it was this one. Because it can't change. I think there is a point a bit closer to that. Okay. Let me go back to this. Oh, maybe I did on the other side, the other way. Okay. Let me say BD. Just to display the point numbers. Okay, you know, when I was measuring, I made a mistake. I started from this one to here. You get it, right? This is the side. But we are starting from this side. So BD, from there to there. Okay. So we have, now, when we are going to create this panel, what we use, it is this angle, this bearing, 320, 48, 55. Not the degree, minutes, and seconds. not the decimal. So we are using degree, minutes, and seconds. DMS, right? That's the one we are using. Okay? Now, if you press the 328.15, it's going to give you errors. It will not work out. So you use the DMS. I hope you have gotten me clear. So now, what comes next? We know that, right? We can either go to underground tools, we go to design, underground design, right? Underground tools, design underground tools, then underground panel layout. Underground panel layout, right? Design, underground tools, underground panel layout. Or we can go to this tool here, which is on the two bars, right? So you can see that these two underground layouts is the same as this on our top, in the third row on our top left corner. So that is the same function, right? So we are going to click on that function. We are going to come here, or we can use this function here. So I'll click on this function. Now, when you read here, it is saying select the panel center line start point, right? Where are we starting from, right? Going where, right? So we need to know which one is our starting point. So we are going to click on that, our starting point, okay? So I'll click on this starting point. Then it will open up this dialog, which is underground panel design. Now you need to understand how those parameters are working there. So now, we have a string. What is the string number that is going to create, right? String. Then now, number of heading to the left. Okay? The number of heading to the right. So now, we have the right and the left. Okay? Then we have the length of heading and loadway spacing. Right? Length of heading, then loadway. Then we have the bearing of the heading. So the bearing of the heading is what we have calculated. Okay? The range of the heading is what we have calculated, which is the distance here, the horizontal distance is equivalent to the vertical distance. So that distance, right, goes on the same level. So that's what we have there. Then length of the spacing, we have assumed in this case that we are going to press a crosscut each 25 meters. And that 25 meters, we are assuming that our scope is of 50 meters, right, which is not stable. It will not be stable. You should know, geotechnically, it's not stable, right? We have a scope of 25 meters. Then whatever. We are considering that even within that 50 meters, meaning you have a pillar, right? Now that pillar, if you have a stop within that length, then you are going to need a lot of waste, so you have to be careful with what you are doing, right? If you are mining engineers. So in this case now, we know the bearing, we know the length, then we know what will be the roadway spacing, right? Now, also, we have the crosscut here. Then we have crosscut spacing. The crosscut spacing, how are they spaced? Roadway spacing is how are the roadways spaced, right? Okay. Now, we have angle heading left. Okay? So to the left, right? Then we have angle main heading to the right. What is the angle to the right? Right? So we have two ways. If we have two bodies, we can do like this. If I put 45, it will reduce just like that. So it can be at 25, whatever, right? So that's how it is going to be. Now, number of headings to the left. So if we say number of heading to the left, what it's going to do is if this is the drift, right? I'm going to have 1, 2, 3, right? That's what it's going to have. Now also we have light. On the right hand side of that drift, right? Or we are saying the footward, right? It's going to have 3 this side, 3 this side, right? Panels. So those are the panels it's going to create. Now, let's press our values here and see what it is giving us. So now, our outboard in this case is on the left, right? So we are just going to the left. I'm not going to the right. So I'm putting 0 there. And we are not going to have 3 panels going this side, we just have 1 panel. So it is just going to go in the outboard once, right? So it will be 1, right? It is the string, you've seen it where it is, right? The beginning is on this side. It is in the, actually, it is in the XZ in the plane, right? The plane view. So now, number of heading, that is 0, we don't have anything. Now I'm going to copy this one here. This angle here, I copy that and place it there. Okay? Now, length of the heading. What is the length of the heading? We said 20 plus 139, right? 20 plus 1, what is this? So it was 139 plus 20. Yeah? 159, right? 159. Then we have a roadway spacing. I'll leave the roadway spacing 0, and I'm going to move crosscut spacing. We are saying they are 25. So each 25 meters, we have a crosscut. So I'll press this. Okay. Roadway, this will be the same with that one. Then place, right? Okay, so the roadway spacing and the crosscut spacing, they are going to have the same values. So from that point to that point, we have created. No, there is something that I've confused here. Something is confused. I'm sorry. Let me return back here. We are going up to that. So there is somewhere where we left something. Let me place the, oh, sorry. This, okay. One, okay. Oh, so I need to go back here. BD. I need to claim again the parameters, okay? We have claimed the parameters there. Then you pick this. Now this we know. So this here, this one here, right? The slope distance here. Is what is coming here. Now, the roadway spacing is what we calculated, which is the 159. You get it, right? We have a roadway here, and we have a roadway here. That are at 159 spacing. So that's where the confusion was. So now, the 159 comes here. The 25 remains there. And at 90, then the light is 0. Okay, now things are correct. So depending on which angle you are attacking, because there is a 90 there. That angle there, this angle we have here, it ranges between 5 point something to 90. So it can't be 0 and it can't be greater than 90. So it has to be within that range. Okay? Now 2, this angle can be modified based on the geotechnical investigation. How are the joint sets crossing the excavation? Because you are avoiding the voids, right? So we need to know at which angle can we attack or can we access the ore body based on the geotechnical investigation, right? When we know the joint set, how are they trending, which direction? If I create an excavation here, what possible failures are going to be created? How can I reduce on the artificial support, right? We use the natural support if we know the joints. Because we know that joints are the planes of weaknesses in the rock mass. Not so. Okay, this is not just continue. So now if we have done the inputs here, what we need just to press is the apply button, right? So we'll place the apply button and we have them, right? Up to there, why didn't it put the last one, Kambidima? Why don't we have the last one here? 0, right? Okay. So now, it's the same. We are going to claim again BD. Now it's the same function, right? BD. We claimed those. Okay. So now we have the bearing of this. So I'm going to get that. Copy in the bearing. And what I'm just changing now is the distance, right? This distance changes. Are we together? Then I will apply. Okay? And okay, there were some questions that were being raised. Maybe some of you were sleeping, I don't know. Like when I went right. So, the question which was raised, right, was this string, what's the string number here? Okay, it's not that. So this string, we are considering as a footward drive. It is part of the ore body, right? Now, our excavation should at least follow the profile of the ore body so that we don't interfere. We have designed that for this excavation to be stable, it should be at 15 meters, right? Geotechnically, right? Now, the drive should follow the profile of the ore body, right? So for it to follow that profile of the ore body, I should get those strings from the ore body. And that's what we did in the past lecture, right? The first lecture for underground. Now, it is going to be 15. If you check very well here, there is this line here, which is this. Let me just go back here. Now, if I do that again, okay, that will come next. We have the spacing of the roadways, right? The roadway spacing. So those spacing, it is creating this roadway here in white and the roadway in white here. And we have in blue the crosscuts, right? Which is, we are saying like we are starting from the ore body on the footwall, going further that way, 15 meters, 20 meters, right? Going that way, 20 meters. So the principle is, when we finish designing these crosscuts, we are going to create one point, right? On the crosscut, which will be at 15 meters from here, going this way, right? Then we are going to move these strings now to that string that we are using as the baseline, right? We move it. So it is going to move 15 meters. Then after that, meaning it is now in the west, meaning we are done, right? We don't want to tamper with the parameters. It's going to be on the same level. We have moved it 15 meters. Mazinzwa ere? Nati mwamvera? Understood? Okay, then we continue. I'll clean this so that we reduce on the bit of things that are there. So now we move. I'll scroll down. We are going to move from this point to that point, right? So there to there. Go back to panel. Now I'm going to be direct until I finish this. First you escape, then you go to panel. Okay? So I'll copy this. There. Okay. Now you can see here there are a lot of kinks here, but we can get a point somewhere here so that we make that to be a straight line. We can't have too many curves. That one also accidents, right? We can have a lot of accidents, and also when we talk of the air friction as we are ventilating, right? Then there will be because too many curves, so you'll be losing a lot of air in the ventilation system. So we can't have those spaces that are close to each other. So we are going to have an assumption that from there to there, actually, we are going to move from here to this point. It is almost in the same bearing, right? So I'm going to click on this point here to that. Okay? Then it's escape, panel, pick that, change. You know what I can tell you? Even here, if you don't know how to copy, don't paste. You paste the wrong things. It will go somewhere else, right? And pay attention very well to what I've done here. You make a mistake. I've put a 0 here because we don't have on the other side, right? If I wanted these panels to go this side 3 times, this number was going to be 2, 3. If you want the same to be that side, we put 3. But we want only one side, that's why this is 0. You get it, right? Then the rest of the parameters, I think it's fine, it's understood. Unless Nika caught, then I'll forget. So, we place. Here also there is a kink here, we are going to have another one straight here, right? You escape, then you start. Do you understand the 90 where it is coming from? What is that 90? Huh? To the guideline, right? The line that we are using as the trending line, which is the strike of the whole body. How is it trending? Okay. Beba. I think I copied a 0 here, right? Yes, there was a 0 in front. That's that. Okay, so we are done. Right? Okay, so we have done this. It's possible also if you want, you can create a separate layer, right? That you are going to place the crosscuts. You can design them in the next layer so that you save them separately, right? Okay, so I'm going to save this as crosscut. There is that surface elevation level to know which level, right? Okay, I'll refresh this. Then let me go to crosscuts, cross. CD, crosscut, C. So this is what we have here. Now I'm going to delete this string, the original string, so that we just remain with those, right? Because it's not part of that. That is the baseline. Okay. Now we can see here. Things are matching up here, right? They are colliding here. So if we have this and that, there is 50 meters here. It is possible you can transport the ore from these stops here on this one, right? Also, I don't need maybe this one here, these two, because you can see that here they are nearby, you can access, you can drill here, right? So now we are going to remove this one and that one. So we are saying we are going to delete this one and that one, right? If we want to avoid this, so that this becomes on the center, we can move a point now. Move a point. We bring it somewhere here, right? Now, here as well, there is a junction there, and these are colliding somewhere there, right? So we are going to break point somewhere there and somewhere there, right? Then delete this point here. Then we delete this one here. Then we join this one and that one. You get it, right? Yeah. Now, we can join also this one and that one. Not so. Now also, we can create that we are coming from here, we go to this point here, right? There will be almost something like a 50. So I can say copy, we copy this one, right? Then we move this one. Let me move a point. Okay. They can start from there. Can be meeting somewhere there. Yes, we can find a way of how to drill, or some can come from there, we drill from there. So it's depending on the accessibility, right? We can do that. Now also we have this, that, okay, this space is so near, so what we need to remove is this one. So I'll remove this one. Now we are going to break point this one, and this one as well. Delete this point and that point. Then join, join this one to that. Okay. Here I'll just join this one and this one. Here there is a bit of some difference, but you can find a way of how to join to avoid that, right? To access. Then I'll join this to that. But here the difference is too much. Okay? So let me join from this point to that point. Okay. Now, I'm going to create a, if I copy, let me copy this one here. Okay. Then I'm going to move a point. I'm going to move a point to a line somewhere, right? We are using a line. Then we snap to point, move a point to that. No. Okay, so we are saying it is starting from there as well. If you want, you can create 25, 25, 25 here, right? Then again, I'm going to copy this same one, right? Then we move a point to point there. Then we snap to a line. We move the point to somewhere. For example, we are saying up to there, right? You get it, right? So you copy, you do whatever you want to do. Then we move now. We have a lot of entangles here. So we have that. Okay. Let's do this. So here we are going to break point somewhere there and somewhere here, right? Then you delete this one, that one. Now here we need to assess very well. Okay, so in general, this is going. This one also can go. Now this one is controversial somehow. Here, this one can be removed, this one, because this one is matching with this one. So I don't need to have it. This one can go. Now this one also can go, right? These we can access here, we can access because they are nearby to each other. Then what we need to do is to join this one to that. Then now, this point will just come there. So we move now, snap to point, we move this point to that point. It's nearby, right? Okay, then we join now from this to that, right? Then now we start copying. We are going to copy 3 lines to segment on the middle there. Also, there can be another way you can do this. I copy this one. We copy this, I'll push it this way somewhere there. Okay, push it there. So I've copied that one, right? So the idea is we are going to snap to a line here, then move a point. This point will go somewhere there. Then we are going to move this one now to a line. I don't want to excavate from this to there, but I'm going to excavate just from this same one we excavate to there. You get it, right? So that we reduce on the amount of spaces that we are going to excavate. Then I'll copy again this one somewhere there. Somewhere there. Okay. So now I can just adjust now the movement of the point, so I can still move this point maybe somewhere there so that we reduce on the distance, right? Then move this point somewhere there. Somewhere there. Okay. Now let's snap to point. We need to snap that line to point, so we need to move this line. Okay. It matches now there. Okay. Also, we can create, because we are coming here somewhere here, right? Instead of this, but this crosscut because going that way actually, I think where are you? Okay. Okay. Just press ERTM. Okay. So something like that, right? It's engineering design, you can do better, but those are the functions. Now, let me save this before. something happened. Now, we know that from this side, we want to move these strings, move this way, about 15 meters, right? So we need to create a point on this string. From this point, somewhere where there is a 15 meters, we are going to create a point there, a guiding point. So we are going to go to create point, then in line adjacent point, insert a point after only line between any 2 points. So only a line between 2 points. So that will be from there to there. Let me change to point so that also these 2 points, these functions are here as well, right? Create point between 2 points, so we can use this one. We place there and there. Then horizontal distance 15. So that 15 meters will be from where we are coming from. We are coming from, if it was from this to there, it was going to be 15 meters from this side to this side. That's 15 meters from this side going this side. Okay? So now I'll save this one. Right? Then we have the footwall, which is this one, right? That is the footwall there we have. So we want to move this one now to that point. So we just say move. We have move string, then we have move segment. So we are moving string. Actually, before I do this, let me, to simplify the things, if they are in different, they have a different number, it might misbehave. Let me try, maybe to work out. Crosscuts, let's bring the footwall, this one. Let's try it. Then we press there. Okay, let's move. We snap to point. So this is the point. Okay. You see what is moving, right? Why? It is because the string for that point is white and the string for the crosscuts is blue. So now the issue is, that's why I was saying, let's try it, because they are in different, they have a different string number. So it will not move things at the same time. So what we will do is we would reverse and you will say reset the, did I say? Okay. I'll reset the graphics. Then I'll bring back the crosscuts where we have that, right? Then we are going to say renumber. We renumber the string. Renumber segments. We just renumber the crosscuts. This one goes to 2. No, this is 2 already. Let's renumber this one to 2. And renumber that one to 2. Why on there are segments? Okay. It's wasting my time. I'm just thinking about that. Okay. So we just go to this. Renumber strings to, or renumber range of strings. So we are going to renumber range of strings. This is range from 1 to 2 to 2, right? So in this case, it will be a bit, you perform one function and everything is done. Then we save this one. After we save that one, we bring back now our drift or footwell drive, this one. Then after we bring this one now, we check in the layer for the crosscuts, and we go to move string. So we move now string, we snap to point, then we place this point to that point, right? Then we save it. Okay. Now after this, I'll go back here. Because these segments are not joined, I'm going to try to join this one to that. This one to that. This one to that. This one to that. This one to this one. Okay, I'll save again. Then I'm going to renumber a segment. This one will be renumbered to 1, right? Then we renumber this one to 1, right? Then we have a point here which is not needed, so we need to remove this point. It's not supposed to be there, right? Okay, so this is what we have, not so. Isn't it? It's making sense? Okay, so let's say ERTM there. We erase the temporal markers. Now we bring our whole body, right? So we can see what we have created, but you can see that due to the whole body, here it is fine, right? It's coming from outside, going into the whole body. But you find that because on this side, the whole body is a bit big, right? It hasn't moved this way, sorry, moved this way. It has gone a bit inside the whole body. Okay, so now this is what we have. So let's now create, we go to mining or the design, underground mine, then triangulate using the center line, right? So we click on that one, we choose the profile, which we know. Now to do this, I've made a mistake. First of all, the crosscuts and the drift. Now we have the footwell drive, right? Together with the hanging wall drive together. But we can put hanging wall and footwell drive together when we have defined them together. But in this case, this other road wheel was just a guiding line. So we don't need this guiding line here. What we need is only the footwell drive. We are considering that in this design, there is no hanging wall drive. You get it, right? So now after we have done this, this comes there, ERTM. Now, we are going to create now the profile. We go to design, underground design, triangulate the center line. We choose the profile. Now, what happens is there is a profile scale factor. If you press the profile, you change that profile scale factor to another number, you may find that the excavation is going like this, or it becomes bigger, right? And when you change also the factor, you may increase on the, if you calculate that how much waste are we going to transport as we are creating those development openings, right? So you increase that value. When you're going to calculate, it's going to calculate more. So if you increase for visualization, you need to know that there is a factor of 4. So that factor of 4, you should know that I have multiplied the amount of waste I'm going to transport 4 times. So we need to remove. Right? So in your calculation, you are going to increase. Boss, não vou não sei. Eu vou cozinhar aí. Vou dar um gato. Puta que... Me, if I sleep 2 hours, I will be awake. It's not healthy, right? But if I sleep just 2 hours, I can wake again. And if I sleep in 2 hours, I sleep 2 hours, I wake up. If you find that I sleep, you send me a message. After 2 hours, I will be awake and I can reply. Then I can only sleep after again 2 hours. So I have to wait. Yes, always forget about that. You eat in steam. That's why I don't take it. It makes you become lazy. And that's why we are lazy. So we are saying when we increase that, it will increase, right? So now, what we need, we said, if we choose the triangulate face, it crosses. We don't need to cross at the end, right? We cross everything together. But if you want to see inside that it is open, you can leave them open. So we are going to press this one, cross. I have not changed any parameter here, right? Apply. So I'll choose the footwell drive. Then I'll start choosing now this. You know, on the mouse, to move the things down, you press the scroll button, you place it continuous, then you can shift things like this. Or you place the 2, then you can move. Right? The right and the left click, you press them continuously. Without releasing, you can move. Vamos ver. Mazinzo. Tatenda. Okay. So you see what we have is something like that, right? I need to bring this one. Yeah, where are the other stop or slice? Ramp. We didn't create for the ramp. Yes, sir.
Someone connected my keys, so before they go, I want to go and get them.
Okay.
Alright. This is all for today?
Yeah, you can go.
Okay.
Why, Museka? What is happening? What are you laughing, Kamitima? Kamitima, there is something that we are discussing that I don't know. The assignment. You want to get free marks, eh? Umuntu ku Okay, this one was a bit up. Okay, what I will do is let's see. It was 809, eh? Okay, so now let me go to design. Then we triangulate profile. We need the orange, H, this one. So we go now to triangulate. That we pick profile. Okay. Yes. That's good. Okay. So now we have the orange, we have the ramp, and we have the crosscut. So you have to go develop something like this for all the levels, right? Okay?